Kubernetes for Humans.
Hello, everyone, and welcome back to another episode of Kubernetes for Human podcast. I'm ETL Schwartz, and I'm your host today. And with me, we have Pini Reznik. Pini, happy to have you.
Thank you for inviting.
Usually we start by you introducing yourself. What are you currently doing? And if you can also share a bit about how did you start using technology and a bit about your own personal journey.
Yes. So my name is Pini Reznik. I'm sort of originally from Israel, although I wasn't born there, but I started my career in Israel in Checkpoint and half of Israeli high-tech, I guess. So I am software development by education, and most of my career spent as software configuration management, sort of, right? So doing build servers, version control, stuff like that. So basically internal development tooling for more than 2 decades now, I guess. At some point, I get to Holland, where I live now, and spent some years in TomTom, which is quite a big GPS company, and eventually started a company called Container Solutions, and as a co-founder and CTO and all kind of other positions. So the Container Solutions was basically, it was all started because of Docker. Right, so at that point, we were looking into continuous integration and DevOps and stuff like that. And when Docker just came out, it was instantly obvious to me that it was exactly what I was doing before, with all kind of weird tools like chroot and all kind of other different.
But back then, you worked in a company, or were you like a consulting or something like that?
So I was in a tiny company called Ugly Duckling. Basically when Docker started, that's where we decided to start Container Solutions, which would be a consultancy 100% focused on containers. That's why Container Solutions, which in hindsight wasn't the best name, but
why not? Like
who cares about containers these days, right? So it's like it's a name that's sort of stuck in the past, and it's not like containers are not important; they're essential. But it's like so deep in infrastructure, who cares? It's like given like air and water.
Mm-hmm. So So what people do care? Like if you will need to rename your company, like for these days, what would it be?
So at some point we very strongly went after cloud native. And by the way, I'm not part of Container Solutions anymore. So just I sort of felt that I wanted to do something else. But in Container Solutions, we went all into cloud native. So cloud native is a bigger topic, and we also saw that it's not purely containers and orchestration and microservices, but it's a broader topic that also includes organizational structure and culture and all kind of things like that. We even created cloud native maturity matrix that was showing much broader concept than typically presented by, let's say, CNCF. So today I would say I probably wouldn't use a name like that anyway, but I would be sort of like cloud native consultancy or cloud native solutions, because it's much broader and more complete.
Okay. And I can't hear you. Like your internet is broken a bit.
Mine?
Yeah, I think so. So now I think now you look okay. So maybe share a bit about people come to you. You guys were helping other companies, right? So what was usually even before that? You talked about how were you introduced to Docker, right? But when did you start using Kubernetes what company? How did you perceive it? And your general take on that Kubernetes in general?
And just sort of for the background, we started in 2014, right? And we actually started talking about containers even in the beginning of 2014. And we started the first meetup, Docker meetup in Amsterdam in early 2014. So what it means is that there was no Kubernetes, obviously, right? So the only scheduler available at that point was Mesos.
Mesosphere, yeah.
There was no even, I think Mesosphere already existed, but it was as young as we were, right? It was a tiny company with few people. So it took a few years until Kubernetes arrived. And there were, if you remember this, there were scheduler wars, right? There were all kinds of different things. Like there was at some point 12 of those with 3 major ones. 4 actually major ones.
Who is the 4th one? Nomad?
Yeah, I guess. There was a point in time when Nomad was like trying to get there. But then Docker, I guess, lost that war, and Mesos too, and for whatever reasons. And then Kubernetes wasn't immediately obvious that they will become something.
Yeah.
So, but it was very interesting to be part of that journey, because at that point we were very involved in the community, and community was tiny at that point, right? I would know more or less all the founders of all those companies and all the people in CNCF, and there was a lot of competition, but also I think the main reason Kubernetes won that war because it was much more open and community driven rather than closed and commercial.
Yeah. So like you started like working a bit with Kubernetes. So now maybe take me a bit to like, usually what we talk about in the podcast is like companies trying to utilize Kubernetes for their business needs, right? So we interviewed here a lot of like platform engineers, but you have a different like point of view, I guess, as a consultant, right? Like you see a lot of companies. So share with me like the classical, I'm like an old company, let's say, right? Like I have my legacy system. Let's say I'm using like Java and like Spring, I don't know, like let's not be super old, but semi-old, right? And now I come to you and I ask you what is the typical customer? What's the typical customer journey? What are the pitfalls? Walk us through like a day in your life.
I think, so most of the time people would come to us and say, we decided to go to, public cloud, Kubernetes, all the, buzzwords, they just came back from KubeCon or something, and we want it all, and we need an engineer for a month to set it up. I'm like, okay, let's pause for a moment. First, let's understand the business needs, and if we give you a good engineer for a month, obviously a person can install Kubernetes, right?
Yeah.
We can even do it probably in 10 minutes in simple version, right? But that's not the point, right? So I think, especially in early days, let's say 3, 4, 5 years ago even, there was very little understanding what it actually means to use Kubernetes. Right? People wanted Kubernetes. That's why, right? Let's buy like a really, really big and fast plane. But do you have infrastructure around that? Do you have internal processes to support this? Can you do, like, if you cannot do some sort of continuous or semi-continuous delivery and your architecture doesn't support it, and your application is heavily monolithic and doesn't fit on this kind of platform, then there will be a lot of struggle. And it doesn't mean it's not worth it, but there will be a lot of struggle, and you should be prepared that it will be multi-year project, transformational for the business, right? So, and it's a quite big story. And eventually some of the companies that we worked with, they understood that it was transformational change that required significant investment, time and money. But others just wanted to install the tool and stick something on it.
Okay. So like now when like a company comes to you, like, are you building like a roadmap for them? Like what's the let's say that, I'm a company that now wants to migrate, right? Like, what would be your biggest advice? Like, I don't know, like 100 engineers, 10 people in the ops, we are using like EC2, bare metal, whatever. So what would be like your advice? What is the expected timeline? What is like the biggest pitfall?
Yeah.
Question.
It sounds a bit like a sales pitch, which is, I did that quite a lot. I think it's very important to pause for a moment and actually do a bit of strategy. Like, you cannot replace just a bit of thinking with a whiteboard in the beginning of the project, right? So it's very important to understand what is available in the landscape, right? There are certain tools or products or projects that shouldn't move anywhere. There are all kind of reasons to move to the cloud. You need to understand the business reasons and connect them to technology. Because Kubernetes is difficult, right? It requires extra education. Most of the people in your organization probably won't understand how it works, or will not have the expertise or experience to actually maintain it. So there's some sort of educational journey. There is some categorization of applications, because the landscape is typically very complex, and we like talking about homogeneous applications that you move over, but it is never like, right?
Yeah.
There's probably about 100 applications, some of them a bit more modern. So it's not like they're all in Java, right? Some of them in COBOL. Yeah. There's still plenty of those. All kind of like PHP and Java and all kind of weird, and then you have some Go piece, and you're like, okay, let's stick that Go piece on Kubernetes. Okay, amazing. So now you have a tiny application that brings €100 a month, right? And now you spend 2 million to create entire infrastructure, but you cannot use it for anything else because everything else is COBOL, right? Now, are you going to rewrite everything? Now, if you rewrite everything, then that's typically ends badly. Right? So you see, there is like, you actually need to understand the current landscape, the business goals, the applications. Are they changing often or not? Is there a scale? Is there a need for scale? Because it's much more, in many cases, it's much more reasonable to just keep them as they are. Right? If you have some new application, old application that doesn't change at all, maybe twice a year, and it's written in COBOL, then it's not about repackaging it and putting in Kubernetes. It's about creating some sort of roadmap of value creation in new modern languages, on new infrastructure, and gradually rebuilding the functionality in the new area, rather than full rewrite for whatever reason, because it's old and outdated, right? So there is no simple answer, actually, what needs to happen. But on average, a transformation of 100 developers company to fully cloud native setup is a multi-year project. So it's like, you can, if you're effective, you can get to production within 6 months, typically, with a tiny piece of functionality. You typically can have meaningful setup in the cloud on cloud native within a year, and you can get fully cloud native within 2 to 3 years.
2 to 3 years. I think, like one of the biggest, I think, like drawbacks, it was really common like a few years ago that people thought that the migration process is going to be like, like a 6 months or something like that. I remember talking with a VP R&D, like a director of engineer of like a very big Israeli company. And he told me, like 3 months, they are already in staging, 6 months to production. And I told him, like, I don't think you understand the Kubernetes as well as you think that you do, because there are so many. It's mainly like not like places to fall, right? Like hidden.
I couldn't move it. You keep using this word, but I'm not sure you know what it means.
Yeah. And, like I will say, like, again, like a couple of years have passed since then. And I think now they're like 30% Kubernetes or something like that after 4 years. And again, it's hard, right? Like, I don't think it's because they are bad. I think it's because in the end of the day, what people really care about is like business value, right? And Kubernetes by itself is not a business value. It is maybe an enabler for business value. But it's hard.
That's exactly what we would say to customers. They are, with small exceptions, they are not in the business of building cloud native platform, right? They're in business of finances, automotive, or retail, or whatever, right? And for them, a cloud native platform is just means to deliver value to their customer. So they cannot just like do it because it's fancy new thing that Gartner recommends, right? Obviously, it's valuable, right? But you need to know how it actually works.
Mm-hmm.
And it is like there is no question it's a multi-year project because again, you need to have a strategy. What is migrating? What is rebuilt? In which way? What's order? Priorities. You need to educate your team. You need to bootstrap the new platform first and then start migrating. It's a complex process, right? And the platform, it's not like you can get a platform. I mean, there is no fully functional end-to-end platform available today.
Mm-hmm.
There is always, at best case, like a couple dozen tools that needs to stick together somehow, and you need to patch them together, and and a bit of duct tape, and it all takes effort.
No, I agree. So let's talk a bit about developers and Kubernetes. Let's say that my organization is now starting to migrate the process. Usually, the one leading the spearhead will be the SRE, right, or like DevOps or infra, or whatever. And then sometimes they also want to include the developers in the mix. So maybe share a bit about that as well, right? Like what do you see? What are again like the pitfalls and so on trying to onboard the developer themselves into this mix?
I think there was, especially in early days of cloud native world or in DevOps, right? There was this DevOps concept. Basically, let's bring developers, put them in the same room with operations, and they will solve all the problems.
Yeah,
this is all amazing, right, when it works, but most people are not just technically not capable of just knowing everything, right? If your operations, you probably spent 15 years perfecting your operational experience, and if you're a developer, you don't care about that, and the other way around, right? So it's there was this attempt to create this unicorn developer operation DevOps people, right? And it's just not practical because those people there are very few who can possess deep knowledge on both sides. Because development and operations are dramatically different disciplines. I think what the main point was that the boundary between those disciplines moved from I package my thing in jar or whatever. I don't even package jar. I just build it and test it and debug it, and then I throw it over the wall, right? And then somebody else will build it for me. And it moved to the point that developers need to understand infrastructure. They need to understand containers. They need to understand scheduling, because actually it is part of application. Distributed execution of the application is actually part of the architecture, and developers need to understand it. So in a way, the boundary moved from I build my tiny piece of application, and then I hand over to somebody else to build it, into actually developers need to build effectively programmable infrastructure as part of their development process. And operations people, NSRE, from different perspectives, they make this thing run, right? But they don't build it, right? They build the platform, but they don't build the architecture of the application. An application is distributed, and you need to understand networking and communication and and packaging and delivery process and everything. Yeah. But it doesn't mean they should sit in the same room and work on the same, on the same backlog and take the tasks that are the same. Those are not the same disciplines.
No, I agree. I agree. So what is the right way? Like, should developers use Kubernetes more? Shouldn't they? Like, where are we going to?
I think there's very, very important point, which is like how to structure the teams. There's team topologies, right? Just obviously the right direction. So you need to have platform teams and value stream teams and whatever. There are 4 types of teams there, and so developers, they are creating value. Most of them. I mean, some of them working on some components. But the point is that developers have to understand Kubernetes, have to have access to Kubernetes, have to be able to deploy the application. Because today, if you run your application on your machine, even if it is in a container, it doesn't represent the full execution environment because that is distributed. And it's like in the past, you would have a single core CPU and you would run your application on single core CPU, and then you would deploy a multi-core CPU and everything would go all over, right? And then all kind of rest conditions. This is exactly the same. So if you develop distributed system that will run on Kubernetes, you have to understand it. You have to test on it. You have to have run environment that is Kubernetes based. But it doesn't mean that you will go and support it in production. This is a complex topic on its own. Like who is supporting what? But yeah, so
I think like who is supporting is the essence. Like who should support in the end of the day, like the business logic versus the infra, right?
Right, and I think that is very important distinction, right? And there's 3 types of teams. There's a development team that actually builds the thing. There's platform team that builds and supports the platform. And there is a SRE team, which the responsibility is increasing quality of both sides, like systematically pushing both platform and development teams to increase quality and stability. For that, they use all the error budgets and all kind of improvement procedures and all the techniques that SREs are using. But essentially, the development team, they build the application and they deploy to the platform. And you need to understand in operations if the problem is in the platform or in the application. And if it's an application, then the support is on the development team with help of SRE. Right.
No.
And of course, you can have the development team is obviously not in NOC, not in response room, right? So they will give some sort of procedures to operational team for emergency support. But overall, the support of the application is on development team, support of the platform on the platform team, and SRE help both to actually do a good job.
No, I think it makes sense. Okay, now maybe let's talk a bit about like the future. Like I always like to ask my guests, like where are we going to? Like first of all, like where are we going? And also, I know that you are working on something new yourself. So I think like so first of all, your prediction, then talk about yourself, please.
I think it's actually related because I do believe that this is essential. What we're going to do is effectively essential for the future. I think we spent the last decade to learn how to work with distributed systems, how to work with Kubernetes, containers, clouds, all these things around. And I think today there's quite few people that actually understand this subject and they can build properly scalable, large, and effective large-scale systems.
Mm-hmm.
I think the next stage is making them effectively optimizing them, but more than anything, making sure that we are actually not destroying the planet by building bigger and bigger systems. I think the future is to make sure that we can actually build those large systems, but in the way that we don't produce too much carbon emissions. We are not destroying the planet, and we are not overspending the money and resources on the things that actually just waste. Right. So those systems exist, but they are not. Most of them are too big, too complicated, not optimized very well, with the emphasis on productivity rather than like in the past, we would care how much bytes would go into the application because it would sit on a diskette or some sort of other weird storage, right? So that would be the limiting factor. And today the clouds allow us to go as big as we want. But by doing that, we are over-consuming the resources, and we really need to be much greener, which is basically that's the direction we are going now, right? To help companies to be eventually net zero, so not just carbon neutral, but effectively eliminate the carbon emissions by certain agreements, Paris Agreement and all kind of other agreements that basically most of the world agree that if we continue growing the way we are, then we won't have a world at some point.
Yeah. So this is what you currently focus on?
Yes, and I think on technical level, the first thing is to understand for every business, and that is very directly connected to Kubernetes, but also to entire toolset, is understand not just how much money you are spending on your system, but also how much carbon you're emitting. And you need to operate your systems considering this, not just saving of money, but also saving of carbon emissions. And all the tools in the ecosystem need to be aware of this. And there is a lot of work to do. There is Green Software Foundation, which is sort of sister foundation to CNCF, and few other foundations and companies that are investing in this. But essentially, the entire ecosystem needs to adjust itself to this future where we as software and hardware people make sure that we are not producing carbon emissions, hopefully at all, at some point.
So how?
That's actually complex. So I think the simple answer, immediate answer is just switch off the lights, right? You have an extra testing environment, extra thing that you're not using, you're afraid of switching it off, just fix it and switch it off when you're not using it. There is all kind of things, over provisioning and over consumption of resources that are not essential, and I understand why people are doing it, because it's risky to delay. It's better to over provision for stability. Well, we have to get to that direction. We have to be able to reduce the compute consumption to the minimum when we actually don't need it. It really is like in your house, that you need to switch off the lights when you are living, right? That's the absolute minimum. But beyond that, the tools are not optimized to save energy and carbon emissions. So, for example, which language are you using? Python, for example, is apparently very bad for environment.
I love Python. So what should we do? Like, stop using Python?
That is a very difficult question to answer, right? But the result is that if you are using Python, the way it's built is actually consuming a lot of energy to provide you more productivity. Right? So eventually it's a trade-off, and you're choosing the side of the trade-off that is productivity, but you are paying with extra carbon emission. Now, if you would have, theoretically, at some point you may have that carbon tax, you would pay extra for using certain tools and languages.
Yeah.
And it would be a commercial decision to actually which language to use.
No, I think that, do you really think that this is what's going to happen, or I don't know, people will pay the tax or do some other things in order to be more efficient?
I think at this point, people don't care because the price is minimal, right? So, for example, if you extract oil from the ground and you burn it, it's very cheap, right? It's cheap because we do it for over 100 years, and so we are very good with it, and we are not paying any future damage, basically, cost, right? That's why oil is extremely cheap. And the same is compute. The cloud compute is very cheap because it doesn't consider the future damage to the environment. The cleanup cost. But that is changing. There is no question it's changing. The regulation, European Union and US and all the other countries, everyone is currently working on some sort of regulation and new legislation to make sure that companies that pollute, they will pay for it, right? And there is, of course, there are offsets, like and all kind of other things, but that's not always real, right? Because they're not regulated, and often people, you pay like extra dollar for to offset your carbon emission from 7 hours flight. It cannot be real.
Yeah.
If it would be that cheap, then everyone would pay.
Yeah.
But it is definitely coming. I think there is no way we can avoid it. The regulation is coming, and I don't know how it will look like. But regardless of regulation, and that's basically forcing companies to be more compliant, I think it's just our responsibility to make sure that all those systems we build, they are actually built in the way that, we keep the planet for our children.
Yeah. I think it makes sense, like what you were saying. Okay. Any last words, Pini, before we wrap up?
Words, yes. Yes, there's a lot of other future things that, of course, going to happen. But this is the thing that I care a lot about, and I think, in general, we have a lot of power. Right, the software is driving the world. It's changing the world. It's creating new social structures and potentially new government structures and everything. And we really need to be responsible with this. It doesn't feel like that when you are coding a bit of, in your home these days on your laptop. You feel like, I'm a good guy, that I'm doing my job and I'm paid good money, but we are responsible for the future, right? And we need to understand how we are responsible for the future and how we can keep it safe and
I hear you. Okay. I think that like we wrapped up. It was a pleasure talking with you. I think like green ops is becoming more and more like real, both from a cost perspective and like the government. So I wish you the best of luck, Pini, and thank you very much.
Thank you.